Hello learners, I still hope it's going well with the geography. Today we're going to actually look at mid-latitude and tropical cyclones. Now your knowledge of the last section would be important when you looked at movements from high pressure to low pressure, weather conditions associated with a low pressure and also associated with the high pressure. So also looking at those pressure belts and our different zones and things like that. So we will use that knowledge. As I say, there are overlaps in our sections, and that is why you cannot learn geography in sections. You have to learn them and then relate each section. So let's get on with looking at the tropical and mid-latitude cyclones as such. I'm actually going to start off looking at the mid-latitude cyclones. Okay? The key concepts here when we're looking at, and maybe I should just make a general comment, is the mid-latitude and tropical cyclone. Let's look at the mid-latitude cyclone again. Okay? Few important aspects. First of all, we need to know that the mid-latitude cyclone is a low pressure weather system. Already you start getting thoughts of what low pressure is and the weather conditions associated with that. Okay? All right? They occur in the middle latitudes of the Earth. Already you start thinking 30, 60 degrees. Okay? They are sometimes called temperate cyclones, the different names given to them, extratropical cyclones, or mid-latitude cyclones, frontal depressions, or wave cyclones. Various names given to them. The common name, the mid-latitude cyclone. Okay? All right? Also, you would note that the system is made up of a cold front and a warm front. You would have picked this up even over the weather report and when your teachers are discussing with you. Remember the cold front, I always call them little thorns, and with the warm front, I always call them little circles or semicircles. Okay? The cold front reached South Africa mostly in winter, when the pressure belts and the wind systems move slightly north. We spoke a bit about the Kalahari High, the South Indian High, etc. They move up, and as they move up, the cold front comes in, and this happens during winter as such. Okay, let's just look at this little synoptic map regarding the mid-latitude cyclone. Okay, you can see again the cold front here, the sign for the cold front. Okay, that's a cold front sign, and this is a sign for a warm front, although this is occluded, etc. We're not going to even look at many things like that, but just remember the sign showing a cold front, the sign showing a warm front. We also will note that there are different stages in the formation of a mid-latitude cyclone. I want you just to remember this. Okay, when there's a slight wave like that, we'd call it the initial stage. When they're separated, we'd actually call it the mature stage. And when they start to join together, can you see it joining together here? We call that the occluded stage. Okay, I am going to give a little more of an explanation with regards to each of these stages. But I just want to show you another diagram. Okay, let's look at the initial stage as such. In the initial stage, a tiny wave starts to be created. And one important thing that we need to remember, that the mid-latitude cyclone is associated with the westerly wind band. Okay, so if there's an obstruction or something of that sort, like the coastlines or a mountain, etc., it creates a wave in the system. And when this wave is created, you find a low pressure towards the center of the wave. All right, and once the low pressure starts to be created, obviously we're going to get a circulation pattern around the low pressure. A circulation pattern. Remember, it's southern hemisphere in this sort of diagram, so we're going to get it in a clockwise direction. If it was the northern hemisphere, then we're going to get an anti-clockwise direction around the system itself. Okay, so once we got this wave, we start off the process, the initial stage. With the mature stage, and people, I know it's a far more detailed explanation regarding this, but I'm going to go just briefly, so I'm going to show you how to identify it and what to look for in terms of the system itself. Okay, when we come to the mature stage, we find that the system has developed into a more circular pattern. Okay, although it's an open pattern, but a more circular pattern where we have a definite warm front and a definite cold front are separated. And now your pressure system is actually, or your low pressure system is actually well developed in here. Okay, and you can still see your circulation patterns. All right, it's clockwise because it is the southern hemisphere. Also, we would get now that these two fronts would actually divide or create two sectors. In here, between the two cold fronts, or between the two fronts rather, the warm front and the cold front, you would get something known as the warm sector. Okay? And behind the cold front, you will get something known as the cold sector. All right? So these fronts actually divide it into two different sectors. But the main things we need to know about the mature stage, that it has a well-formed warm front and a well-formed cold front, and they are separated. All right? There's two definite fronts. At this stage here, we didn't have two definite fronts. Okay? When we look at the occluded stage, we would actually find that in the occluded stage, there is joining of the fronts, as you can see it down here. Okay? This actually means that the cold front now has caught up to the warm front. And as it goes in, remember the warm air is light. Okay? It's energetic. And the cold air from the cold front is heavy and dense. So if we visualize this, that the cold air catches up to the warm air, all right? It's catching up to the warm air, and it creates a sort of wedge because it's cold and the warm air is light. And what actually happens is the warm air is pushed up, all right? Eventually, as it goes through, the warm air is pushed up and the system becomes a cold pool of water. And that's when the system actually disintegrates. All right? And those are your different stages of the mid-latitude cyclone. Okay? Now, I want to look at this, and this seems to pop up quite often, is the cross-sections of a mid-latitude cyclone. What I've done here is I've split it up into two different sections. I did the warm front condition separately, and I will do the, or rather the cold front condition separately, and then I'll do the warm front condition separately. Again, it's related to temperature and pressure. Okay? So let us look at this system. Remember, we're now doing a cross section. We're cutting across, and I just want to show it here. We're cutting across the system, and we're creating a cross section, and we're looking at it. as how it looks from this angle here. So we're cutting across the system and we're looking at how does the mid-latitude look like from this direction. Okay? And let's look at what we got at the cold front. Remember, it's cold air. And before this, you had this warm air in front of the system. You had the warm front. Okay? And now this cold front comes in. So when the cold front comes in, obviously, temperature decreases. Okay? Because it's a drop in temperature. Pressure at first would decrease, but as the cold sector comes in, okay, it could increase. All right? Or rather, it increases. So the pressure starts to increase. Okay? Humidity decreases. There's condensation happening. All right? It's the cold front is coming, not bringing in much moist air. Okay? So the humidity decreases. Cloud cover increases. Obviously, cloud cover increase. We had this water vapor, and all of a sudden you had this cold air coming in. And what does it create? It creates condensation. So cloud cover would increase. As you can show down here, we can see massive cumulonimbus clouds, huge, standing in the vertical extent. All right? Massive cumulonimbus clouds which are coming at that stage. All right? Chances of precipitation, very good. And we have some, in many occasions, heavy rainfalls coming with this because it's huge clouds. So heavy rainfalls are occurring at that stage. Okay? Wind direction changes, and it's stronger winds. Because of the condensation happening, etc., you'll find the wind directions veer. There's no set direction. They just come in from all A's, and you get a stronger wind. We actually see it in our real lives also. And many people say, especially during winter, if you notice that, suddenly everything just still, and then you get this wind starts to pick up. And people generally talk about, I think a cold front is coming in, even without looking at the news or weather report. You understand? A cold front is coming in. And that's one of the things that, or one of the characteristics of the cold front conditions. Okay? So quite a few that happens in that phase down there. Okay, let's look at the warm front conditions on the other hand. The temperatures are higher. So when the warm front hits an area, the temperature increases. All right? Remember, air is rising, so pressure decreases. All right? Because the air is rising. Also, it's warm air, so what is it doing? It's absorbing moisture. So if it's absorbing moisture, the humidity increases. Okay? Cloud cover, nimbostratus, because it's quite warm, there will be a certain amount of condensation that will occur as air is rising, but not as rapid as a cold front because temperatures drop and there's a vast or greater amount of condensation occurring with regard to the cold front. Here we may find nimbostratus clouds. Precipitation. Let me just refer you to the nimbostratus. You notice it's not very small, but not as huge as the cumulonimbus clouds. All right? Precipitation, soft soaking rainfalls. All right? Not this heavy rainfall, but soft soaking rainfalls. All right? I just want to emphasize something down here in terms of our movement of our cyclones. All right? They actually move. If you look at our our mid-latitude cyclone rather, they also have a set movement. All right? And mid-latitude cyclones move from west to east. All right? Reason being that it's part of the westerly wind belt. So therefore, it moves from west to east. The next thing that I find learners actually have difficulty in, and when we mark also we find that this is the situation, is that when we look at occlusion, the occluded stage as such, all right, that is when the cyclone is starting to die out, when the cold front catches up with the warm front, etc., and the warm air is pushed up. We have two types of occlusions that happen at this stage. Okay? Now, let's look at the first one, a cold front occlusion. Here, one of the ways of identifying a cold front occlusion is when you look at the temperature ahead of the system and you look at the temperature behind the system. So generally, the temperature ahead of the system is higher than the temperature behind the system. Okay, so if I put maybe 8 degrees Celsius here, I would put 7 degrees Celsius there. Okay, it's lower than that area. I'm trying to put in some figures to tell you that it's not 35 degrees Celsius here and -2. It's just that the temperatures are higher. When I teach a section, although it may not be totally geographically correct, but learners seem to identify this, that I say that the cold front seems to cut into the warm front. It helps them, as I say, it may not be geographically correct, but it does help them identifying this, that you can see the cold front is fully formed and it seems to be cutting into the warm front. It actually makes learners recognize whether it's a cold front or warm front occlusion. All right? Let's look at the warm front occlusion. Okay? With the warm front occlusion, it's the opposite actually. If you look at here, it's cold air, and here it's cool air. Okay? And the cold air down here, let's put a temperature figure at the same ones, 7 degrees, and here 8 degrees Celsius. All right? So it tells you that. Okay? That the air in front of the system has a lower temperature than the air behind the system. And I'm using my old point again, as I say, it may not be geographically correct, but it makes learners understand that. All right? If you look at this, the warm front seems to be well formed and it seems to be cutting into the cold front. And from this, you can actually identify your warm front or cold front occlusion. This question seems to be popping up a bit more often. You understand? So we do need to know that, not just identifying the stages, etc., and looking at the cross-section as such. Let's go further. There's a satellite photograph. Okay? On this side, you can see the cloud cover showing you the two different ones. But you notice something here. At the cold front, the cloud band is very tight. And you see it thick. You can see a white cloud band there. And when you look at the warm front, it's not as concentrated as the cold front. Again, when you're looking at your cross-section, you remember that the cold front results in cumulonimbus clouds, large cloud cover, overcast skies, etc. And the warm front does sort of result in cloud cover, but not to such an extent as the cold front. So the warm front has your nimbostratus, etc. And you can see it on the satellite photograph here. Okay? That it's much less dense compared to this area here. All right? Few other characteristics, as we mentioned again, and I'm saying it again down here. Southwesterly wind coming in, you understand, from the southwest, because they do move from west to east, according to the westerly winds, as we discussed in the last lesson. So they move in this direction. Okay? Obviously low temperature again, high cloud cover, precipitation, low pressure. All right? In the air. The northwest wind, okay, the high temperatures, fewer clouds, little or no precipitation happening in that area. All right? Let's look at a synoptic map and look at the effects of a mid-latitude cyclone rather. All right? Also, the effects of the mid-latitude cyclone is also more localized. All right? And we can see it clearly here. Now, in South Africa, we will note that it's the cold front that affects our country and not the warm front. The warm front is too far south to actually affect our country. Let's look at this. You can see these cold fronts, and by the way, when we get a few cold fronts coming in one after the other, it's known as a family of cold fronts that's coming through, or family of mid-latitude cyclones. This is very interesting where you see the conditions here, learners, is we note ahead of the cold front. And if we look carefully down here, we see clear skies. Okay? Then we move into the area where the cold front is actually hitting. And what do we notice? Overcast skies. So already we can see the condensation that is happening when the cold front passes over a region. Okay? We'll notice that clearly down there. Also we'll notice, and if you look down here, the temperature indicates 27 degrees Celsius. At the cold front, the temperature indicates 9 degrees Celsius, 12 degrees Celsius, etc., 13 degrees Celsius. So there's a clear difference in the temperature. And it's very visible on synoptic maps. And it's good to use synoptic maps that you can see this happening. All right? With regards to the changes. As the cold front has passed through, you'll notice areas start to clear up slightly. Isn't it? There's a slight white patch there that tells you it's not totally overcast. Okay, so it's very clear to see on a synoptic map what really happens with these things. Learners, just remember the explanations that I gave you is just a brief summary. Of course, you would have received from us a little booklet giving you more detailed summaries regarding these things. It's quite a big section, so please refer for more information down there due to time constraints. All right, but what I'm going to look at now is the most important thing again, and that's your sample questions as such, because this is where we apply the different information that we learned. All right, let's look at the first question that we have down here. Refer to the satellite image below showing the position of an approaching low pressure system over the west of South Africa and read the accompanying weather forecast before answering the question. All right, we see already the examiner is telling us about the low pressure system that's approaching from the west coast. Already we've got hints even before looking at the synoptic map or the satellite photograph that we know already there's a hint coming in from the west. We know that mid-latitudes move from the west to east. That most probably it's a mid-latitude cyclone. All right, and then we look at it down here. Okay, and we can see it, if you look down here. Can you see it? All right, your cyclone coming in, there's southern Africa there, and it's moving in that direction, coming in from west to east. So that's your mid-latitude cyclone. Okay, satellite image showing you that. Let's read through this. And again, we highlight words. Nice clear skies with cool temperatures can be expected on Tuesday and Wednesday, but people in the Western Cape need to brace themselves for another few cold, wet, and windy days from Thursday. So we're already relating the weather conditions of a mid-latitude cyclone because in our satellite photograph, we identified it already. Again, the importance of reading the information before you answer the questions. Okay? South African Weather Bureau is issuing advisories for this approaching system since the beginning of the week. So it's coming through. On Thursday, gale force, northerly and northwesterly winds are expected. Wind direction again. Cape Columbine and Cape Agulhas accompanied by rough seas. Okay, the winds, the stronger winds, with wave heights in excess of 5 meters. So the cold front and the air is coming from the coastal region, from the oceans, and the winds are increasing, therefore it's creating more waves. Very cold conditions over the western interior and northern Cape, spreading in the interior of Eastern Cape, and a sudden free state can be expected. So we know the cold front is moving over the land. The colder conditions are expected to reach the northeastern part of the country on Saturday. So it's quite a big cold front that's coming in. And we saw the size there as we moved up again. We see the size of the front. It's big. So it's coming through. Okay? With temperatures falling into the cold category. Isolated heavy rainfalls are expected, which could lead to localized flooding expected over the peninsula, Boland, and Overberg. And on Thursday and Friday, the South African Weather Services appeals to the public to forward them any reports of confirmation of significant weather events such as snowfalls. Getting information from the public, taking precautionary measures is necessary. Okay? Hailstorms, heavy rain, and damaging winds. These are the weather conditions. When they are observed, such information can be used for further research, which will contribute to improvement in the weather predictions for that particular area. So it's all dealing with the mid-latitude cyclone, the weather conditions, the change in the weather conditions, the dangers that's going to happen, some of the precautionary measures. So we've read all our information, and obviously now it's time to look at the questions. And there we have it again. Identify the low pressure system labeled K. The low pressure system labeled K. Let's look at this again. K. Now, note what the examiner said. The low pressure system, not the front. But sometimes it can be confusing with the learners and they start naming the front. The system is the mid-latitude cyclone. Okay? So we'll look at a question again. The system labeled K is a mid-latitude cyclone. Okay, let's look at the next question, which we worked. During which season does the above-mentioned low-pressure system usually affect the weather of South Africa? Even without looking at the diagram. All right, you worked out a mid-latitude cyclone. You have learned that it happens generally in winter. Okay? Or it affects the country generally in winter. Give the general direction of movement of the low pressure system. Usual movement mentioned in 1.1. We've already picked it up as we discussed earlier on. It moves from west to east. All right? Some people talk about southwest to northeast. It's still fine. You're actually being a bit more accurate than I am at the moment. All right? But the general direction is west to east. Give one reason for the direction of movement of the low pressure system as mentioned in 1.3. And again, we've done it. We've spoken about it's part of the westerly. It's part of the westerly wind band. All right? A westerly wind system, etc. So the westerly wind system, and that is why it moves from west to east. If you remember, we discussed that in the last lesson that we did, or session that we did. Okay? Let's look at the next one. All right? Draw a sketch of the low pressure system appearing on the satellite image indicating its position in relation to South Africa. Very simple. let's just get back to this little one that we did. We can see it here. There's your cold front. There's your warm front. And we see it clearly. All right? Shown down here. And there's Southern Africa here. So in a question like this, it looks, how do we expect to draw a sketch? It's quite a difficult. Actually, it's very simple. It's a rough sketch. We don't expect you to be accurate. All right? So if you remember this, let's get back to the question. All right. All I need to do here is, and my sketch of Southern Africa doesn't have to be accurate. Whenever I teach, the sketch keeps changing. All right, so I could just draw Southern Africa down here. All I need to do is, I remembered my position. I draw it. Okay. I put in my cold front signs, and I put in my warm front signs. And I've done my work. Okay, that question was for 6 marks. How do we mark it? And the position. And 6 marks. 6 out of 6. Just simply drawing it. So the idea is to visualize, to see, to use satellite photographs, to use synoptic maps, not just learn your work out. Because some people find this difficult, yet it's one of the easiest questions you can actually answer if you know your work and know how to apply it. All right, let's look at this. All right, I know it's your favorite, the 12-mark question. But learners, you don't have to be scared of 12-mark questions. You understand? And no more does, and I left this here, no more says no longer. Okay? And some of you may get the past papers that say no longer. It's now approximately 12 lines. Eh? And do not get scared, learners. If you write small and it comes less than 12 lines, we look at whether you have 6 points, because it's 6 times 2. If your writing is bigger and you take more than 12 lines, you understand, it doesn't really matter. We will mark it if it's 6 points. We put this in to avoid people writing essays, and what happens is they waste a lot of time answering the question and then don't complete the paper itself. Okay, let's get back to the question. Why is it important for the South African Weather Bureau, important for the South African Weather Bureau Service to issue weather warnings? Okay, use the source, weather warnings. Why is it important for them to issue weather warnings? Okay, so immediately in this, we're looking at a statement about the necessity for weather warnings, the importance of it. Use the source above and write a short essay, approximately 12 lines, clearly indicating the value of weather forecasts and warnings, and also indicate how reports forwarded by the public can improve the weather forecasts. Okay? So, if we look at the question here, okay, the importance of weather forecast and the warnings, and also how can people improve the weather forecasts. Both are relating more or less to the same issue. So we don't have to now really go to great extents to sort of separate them. Now, you know the weather conditions, but the fear here is that you start talking about a paragraph, and that puts fear into you. Many of you can explain it in a point, all right? But when you talk about a paragraph, you get scared. I could start off with a thing like this, and I could take the same points that you write, you understand, and put it into a paragraph, okay? I could start off as, let's look at here, the value. I could say it is important. I'm not going to get a mark for this. It's important, all right, to have a weather, I'm just going to put in short, weather forecasts and warnings. Okay? I put a full stop. And then I start my my discussion, and it be in points, but I put it as sentences down here. Okay, I could state that it helps us take precautionary, I'm just going to put in short, precautionary measures. Okay, unfortunately I want to cover a few more, so I would run out of time, so I'm going to do that. Full stop. Okay, it helps people to find shelter. Full stop, if you want to write it short. Okay, it helps tourists in terms of their plans for the day or change of plans for the day. And what am I doing? I'm adding on points. So you've explained your points, you understand, in terms of putting it in point form. All you need to do is take the same points and put it in a paragraph with full stops in between. There's many others. Okay, it prepares the emergency services. Okay, it brings in necessary stock in terms of food supplies. Okay, in terms of medication. All right, it moves people away from the area that's going to be sort of affected by the storms, etc. Okay, so there's so many answers here. I know which you know and which you got in your material. Okay, so all we need to do is have 6 of these. This part, of course, we wouldn't give a mark for, but you like to maybe start off with something like that, and you write 6 of the factors that affect would make a difference. All right, and that gives you your 12 marks. Okay, let's look at this one, guys. Similar, illustrating weather system that develops over the west coast. Choose a correct term from answers given in brackets, and this is more a multiple choice or selection of correct answers. Again, we see the system in the mature stage. We see the cold front, we see the warm front, and let's look at some of the questions. The sketch illustrates a tropical mid-latitude cyclone. It's mid-latitude. You know it already. All right, let's go to the next one. The weather system illustrates in figure 1 is in the mature or occlusion stage. You see nothing has joined. It's still separated. This system is separated from this front, or that front is separated from that front. So obviously it's in the mature stage. Let's look at the next one. Okay, air rotates clockwise or anti-clockwise around the system. If you look at it here, you can see definitely the arrows are pointing clockwise. The weather system generally passes over the Cape Town during winter or summer. Again, from your knowledge, you know that it passes during winter. Okay? The front label P is a cold or warm front. It's a nice one for your revision to see whether you understand your work. Eh? All right, so it is a cold front, P. You can see that this is the warm front. All right, I just want to show you, in fact, this didn't actually come out very clearly, all right, which shows you a satellite image of a mid-latitude cyclone, okay, and then the synoptic map of that mid-latitude cyclone. Okay, and then it's a series that's happening here. Okay, and then there's a little summary again about the expected changes in the weather system with heavy rainfall, etc. Notice it's similar type of questioning, but phrased differently with different types of diagrams. And here we could look at provide evidence from the synoptic chart indicating that P and Q are tropical cyclones. All right. Sorry, let me just go through here. Very easy. If you look at P and Q, all right, they are warm fronts or cold fronts and warm fronts. That alone tells you it's a tropical cyclone. So with the first question down here, and provide evidence from the subtropic map that P and Q are mid-latitude cyclones. You can talk about there are cold fronts and warm fronts. Okay? Next one. Which one of the mid-latitude cyclones is most likely to be older? Okay? And we look at our system again. In this sort of question, which one is more easterly? Is it P or Q? Obviously, Q is more easterly here, if you look at it. So therefore, that is the first one. This is happening later. Okay? So most likely to be older, definitely Q. Okay? Give one reason for your answer, because it's more in a easterly direction than the P itself. All right? With reference to the satellite image and synoptic chart, explain why the Eastern Cape is experiencing rain and very cold conditions. And if you go back to our synoptic chart, what we'd notice that the cold front is over the Eastern Cape. Can you see it there? Obviously bringing colder conditions and condensation and rainfall. Okay? Okay, let's look at question 3. It says, with reference to the satellite image and synoptic weather chart, all right, satellite image and synoptic weather chart, explain why the Eastern Cape is experiencing rain and very cold conditions. And if we go back to the synoptic chart, all right, and we look at it down there, the satellite photograph is not that clear, but on the synoptic chart, as you can see down here, the cold front is passing over the Eastern Cape. Already the conditions of a cold front come to mind. You understand? It's cold, it lowers the temperatures, increases condensation, etc. Okay, let's look at the question itself. With reference to the satellite image and synoptic weather chart, explain why the Eastern Cape is experiencing very cold conditions. All right, so we know number 1, it is the cold front. The cold front is affecting the area. All right, and many people get confused now. Do I repeat things? Because it's talking about cold conditions, it's talking about rainfall. How do I go with getting 8 marks there? I need to give 4 points. So we're talking the cold front is being experienced over Eastern Cape. What else can I write here? All right, the cold front, all right, will decrease temperatures. Okay, the cold front will result in more condensation. Isn't it? As condensation occurs. And when condensation occurs, more cloud formation. Okay? Therefore, more rainfall. So already I've got 4 points here. All right, talking about these issues and the cold conditions. First one, the cold front is hitting the area. All right, the temperature decreases, condensation, cloud formation tends to happen. But if you look at your notes that you receive from us, you realize, of course, you have to put it in sentences as such. Okay, because it says explain and not just list. Okay, let's look at another question. Which weather condition not mentioned in this weather report is clearly visible on the satellite image? Unfortunately, our satellite image is not very clear. Okay? It's actually not very clear, but sometimes you would notice as the cold front is occurring here, there was a high pressure system around there, and if there was a high pressure system around there, you could get berg winds happening. Okay? That could be one of them. But in your satellite photographs, you look around for what's happening. Sometimes, even in a satellite photograph, you could get a mid-latitude cyclone somewhere down here, and you could also get a tropical cyclone. That's early autumn. Okay, so you need to find that some of the things that are not here. But the ideal situation here is there's a cold front hitting the coast, so there's a coastal low there, you understand? And there's a high pressure system down here, which could result in your berg wind conditions. Okay. All right. So I could even put berg wind conditions here. Berg wind. Give one reason why it's important for people living in the Eastern Cape to be made aware of weather conditions mentioned in question 3.2. This will be actually quite a nice question to get as a 12 mark also, eh? But in this case, it's just for 2 marks. So I put any factor, all right? And again, it comes through like the last question or 2 questions ago that we did. Exactly the same sort of explanation, all right? For emergency services, okay, to have emergency services available. Services available. Okay, we could also talk about people finding shelter. Same as the other question. I know I may be repeating this, but you see how it's phrased differently. Finding shelter, all right? And so on, as we discussed in the other question down there. Tourists get involved also moving people away from an area, providing the necessary food supplies for them. So anyone would actually give you 2 marks. It says give one reason in this case, not fully explain it. So we can say we can have emergency services available, okay? Or we can get people to find shelter that are homeless, okay? Okay, learners, that's actually some of the questions that could be asked for mid-latitude cyclones. Remember, there are many more questions. These tropical cyclone, mid-latitude cyclones are very popular sections. Okay, so you go through as many questions as you can on mid-latitude cyclones. We will take a short break, and you can go get your glass of water. And once again, remember, it's just a glass of water. And come back as soon as you can. Welcome back, learners. Once again, we come to the important section of looking at past papers and questions that are similar to the examination situation. And once again, we're going to follow the same route as we followed with the mid-latitude cyclone. We're also going to do a little summary regarding the tropical cyclone as such. So let's just have a look at some of the main points relating to a tropical cyclone. First of all, we look at tropical cyclones develop at the ITCZ, okay? Intertropical Convergence Zone. And we looked at that zone earlier on in the last session, and we spoke about it around the equator. All right, it occurs outside the 5-degree north and south, because with the tropical cyclone, we need the deflection to happen. So we need Coriolis force, which is absent at the equator, because when you look at the equator, okay, the air starts to move. And at the equator itself, the air is not moving, so we're not getting that deflection, as I mentioned in the last session. Okay? Also, what do we need is an intense low pressure system. So immediately when we look at the tropical cyclone, vision in our mind, temperature, high temperatures, all right? In most of these cases, again, I told you, we're looking at pressure, we're looking at temperature. So high temperatures. It actually lives on high temperature itself. So in order to have low pressure, of course, there's a high temperature, air rising, and pressure is dropping. Okay? So a low pressure storm, which causes a lot of wind and flood damage. General characteristics about a tropical cyclone, strong winds. In fact, sometimes these winds have gone over 250 to 300 kilometers an hour. I mean, visualize that wind blowing over the ocean and carrying the ocean's water at that speed. Okay? Let's look at a few more points in terms of the introduction. Tropical cyclones only form under specific conditions. All right? There has to be certain conditions, and thank whoever for that. Otherwise, we would be having tropical cyclones every day, and the whole earth will be devastated. Okay? But there are specific conditions. All right? They are named alphabetically in the season in which they occur. Okay? So, and in the region itself. So let's say tropical cyclones in around southern Africa or around the Indian Ocean as such. If it's a first tropical cyclone, we could name it Ann. If it's a second tropical cyclone for the year, it's known as Ben. Okay, so it's the letters of the alphabet. A would tell you it's a first tropical cyclone in that region for that year. B will tell you it's a second tropical cyclone in that region for that year. Okay? I will come back to the conditions, but just a brief overview of this. As we said, it's named alphabetically, like Andrew, Bonnie, Carl, Deborah. Okay? And then the origins again, just to summarize that, in the tropics, over the oceans, because that's where we're going to get high temperatures. Remember, latent heat is going to come in. Okay? Because latent heat, as the air rises, it condenses, and then it gives off that heat. So it adds to heat. Okay, we also said it's not nearer than 5 degrees from the equator, okay, because there's less Coriolis force. All right, we spoke about destruction. It's a stormy, very hard rain, flooding. Okay, and in the eye, we'll talk about this later. It's actually quite a unique situation where we have no wind, cloud, or rain. Okay, and the weather before the eye and during the eye will be totally different. You understand, there's a vortex, first vortex, and the second vortex. So this weather would be different from the eye, where we would have heavy rainfalls, and we would have strong winds, very high temperatures, okay? And then we look at a stage where we're dissipating, all right, where it dies off, where there's no moisture, no warm air, lots of friction, okay? And we look at the destruction that it causes, as we said, storm winds, very hard rain, and flooding, and we look at ways of how to manage it. Early warning systems, track storms, services, inform people, evacuation. But I'm going through this briefly. I will go in more detail as we look at the rest of the content, okay? Firstly, we looked at that our tropical cyclone would form around that region. Okay? It's around 0 degrees, and there's 5-degree line here, and around 5 degrees it starts to form, because that's when we get the deflection happening better. Down here, the deflection is very, very small. So here we get a more pronounced deflection, and therefore the tropical cyclones form. And again, a point to note here is that tropical cyclones form in the easterly wind belt. Remember, mid-latitudes was in the westerly, tropicals on the easterly wind belt. Okay? Another thing we'd look at, because it's the easterly wind belt, all right, it's coming in from east to west, and therefore tropical cyclones affect the eastern sections of the countries. Eastern sections, you'll notice, right through. Okay? Another thing you will note is that they're given different names. All right? A tropical cyclone actually is known as a tropical cyclone when it affects around the Indian Ocean. When it affects the Americas, etc., it is known as a hurricane. When it affects the North Pacific Ocean, like places like Japan, etc., it's known as a typhoon. When it affects Australia, generally, most books call it a willy-willy, and this answer is accepted. I am aware that if you go and research over the internet, etc., Australians do call it a tropical cyclone, okay, and they refer to a willy-willy as a dust storm. But because most of our books have it, etc., we do accept it as a willy-willy. All right? Let's look at those stages, and this is where I'll bring in the I, etc. Okay? Now, in the initial stage, there will be a drop in the temperature. The temperature, or rather the pressure, the pressure starts to drop, and it starts to drop to closer to below 1,000 millibars. It's still around 1,002, etc., but it's nearing that point where it's going to go even lower than that. All right? Already this low pressure system is starting to form here in the initial stage. You understand? Slightly above 1,000 millibars, but already relatively low. At this stage, we could start getting things like swells in the ocean. Okay, swells meaning it doesn't mean a full wave, but you notice the movement of the ocean is actually a bit more rougher than normal. Okay, of course, this picks up, but certain conditions, and I said I'm going to bring in the conditions now, has to prevail for it to go through the stages and go through the immature, the mature, and the dissipating stage. What are those conditions? Okay, let's just put the conditions at the bottom here. For it to form, the conditions are temperature over 27 degrees Celsius, so it must be quite warm. I'm aware that some books do talk about 26.5. It doesn't really matter. If we put in 26.5 or 27, it's still fine. Okay, we will mark it correct. So that is one condition. The second condition, calm conditions. Okay, calm conditions, because what will happen is if there's rough conditions or windy conditions, it's going to mix the air and a low pressure won't form properly. All right, latent heat. Okay, latent heat needs to be present, and of course it's happening over the ocean. So as the air rises and if the temperatures are constantly high, more air would heat up and rise, and with it, it will be taking in the moisture. And as the moisture goes up, it condenses, and remember, when it condenses, it's giving off heat. You understand? The water vapor condenses to form water droplets, it's giving off heat, and therefore giving off latent heat. Also, we will need upper air divergence. Upper air divergence, which must happen. When I mean upper air divergence, maybe I need to explain that a bit more. As the air rises when the temperature is high, the air needs to diverge in the upper air. Because what happens if it doesn't diverge? The air will remain here and will come down, and what will happen to our low pressure system? It will die off. So we do need upper air divergence. So what's actually happening here? It's forming a nice pattern. The air diverges, and as it diverges, when it starts subsiding with the condensation, it starts forming huge clouds around this spot. What is happening to this spot? Air is coming in from the outside because the low pressure is very low in the center. The outside pressure is relatively higher, so air is rushing in and air is going out. Okay, so what's happening to this area? This area is relatively calm. Because as the air is going out, if more air is coming in, it keeps going on in that cycle. And this is where we'll talk later on about the eye. So these conditions are necessary for the tropical cyclone to form. Of course, the area needs to go over the oceans, isn't it? All right, that's where it's going to get its latent heat, etc. If not, and if some of these conditions change, the tropical cyclone can dissipate at any stage. And many tropical cyclones dissipate. Okay? So that is your situation here where the pressure becomes lower. And of course, if the conditions remain, as I mentioned earlier on, you'd find that your pressure will get even lower in this stage here, the immature stage. At the immature stage, we already start seeing the formation of the eye. It starts to form a bit down here. All right? Okay? And the signs of the system getting smaller, the depression in the center gets smaller. If you notice the size, and maybe I need to erase this a bit. Okay? All right? And if you notice the size of the isobar in the center here and the size here is getting smaller. So the depression is forming, the depression of that low pressure is forming and becoming more pronounced. Okay? In the mature stage, you'll notice here it's dropped to 992. In the mature stage, the pressure has even dropped further in the center. All right? And you look at the size of the center there. The depression now is well formed. The eye is well formed. I keep drawing this. This is a symbol to tell you that that's a mid-latitude cyclone. It's found on synoptic maps. So it's one of the things, whenever they ask you, how do you know it's a synoptic map? You can say it's a symbol. You can also say it has a name. Okay? So you notice it's very well formed down there. And this is the mature stage. This is a stage where the pressure, or the temperature rather, together with the pressure, the temperature is very high and the pressure in the center is very low. It's sending out the air now and the pressure is going down. What's happening on the outside at this stage? The pressure is much, much higher. So the air is moving in to this low pressure at very fast speeds, because in terms of amount of air in the both places is vastly great, the difference. There's far less air particles and a very low pressure. On the outside, I have a much higher pressure. So the air is rushing in. And at this stage is when all this havoc happens. Hurricane force winds, massive rainfall, etc. This is the most devastating stage. All right? During this stage. But the conditions have to remain in order for this to continue, remember. Okay? Then we get the dissipating stage. Now, various ways. Remember, the only way I like to say we can kill off this cyclone, I'm giving it some life here, is by reducing the temperature. It works with the temperature, because higher temperature, low pressure. So we change the conditions. Now, this is the stage, and you notice what's happening here. You notice the pressure going higher. Look at the center. All right? It shows a bigger circle. All right? That shows the depression or trough is getting weaker. How would this happen? It would happen when it goes over land, because what happens over land? All right? When it goes over land, with land, we have friction. And friction, what does it do? It mixes the air. Number two, land is dry. There's less humidity, less latent heat. Okay? So land with its friction, etc., would cause it to dissipate. Or, as we've spoken about the middle latitudes, which is lower in temperature compared to the tropics. And when it goes into cooler waters, okay, cooler waters such as the middle latitudes, okay, it starts to dissipate because the temperature of it gets reduced. And by getting reduced, of course, it loses energy and it starts to die off. Okay, this is roughly the different stages which the tropical cyclone will go through. Okay. Let's look at a rough cross-section of, I know it looks like a beautiful diagram, but when we refer to rough cross-section, we're not drawing it according to scale. All right? Look at the cross-section in the mature stage. All right? We got our system moving from east to west. All right? And then we look at here, we have three different things, or different stages. We have the first vortex, okay, which is very stormy and brings in high rainfall and strong winds. Can you see the vortex? Dense cloud, violent winds, thunderstorm, torrential rainfall, massive. There were some areas, I remember the area in Taiwan, it was a tragedy that hit when the cyclone hit in that area where 2,000 millimeters of rainfall fell in one weekend. And if you consider the average rainfall for South Africa is between 500 and 600 millimeters a year, imagine 2,000 millimeters. So it's a massive amount of rainfall that happens. Now, if you look at the eye, you find it low pressure, clearer skies, temperature warmer, calm. Not much happening in the eye. Okay? Remember we spoke about it? As the air comes in from the high pressures, it heats up and rises, and there's upper air divergence. So this air is moving out all the time. From here, it's coming out. So this eye is calm, generally clear skies, slight drizzle, and that's about it. You understand? Then, it's the second part. And this can be deceiving because first it is tragic and it causes a lot of damage. Then it's calm, and then we get the second vortex, which once again brings in strong weather conditions. All right, strong winds, dense cloud, not as strong as that part because this part here has the forward left-hand quadrant, okay, in this section here. And if you look at it, if it's moving, I'll just like to maybe get back to the other slide, okay. This section here, because this cyclone is moving in this direction from east to west. You'll notice the isobars are close here. So it's a steep pressure gradient. Note we're using pressure gradient again from the first session. Okay, so these concepts are used again. So this pressure gradient is very steep, therefore making this the most dangerous section. So, the forward left-hand quadrant, etc., falls into this section here. Okay, it's far more devastating in terms of the weather conditions, but this has a bigger impact. Okay, because what has happened when the first vortex has passed over the area, it has caused damage already, and maybe even the infrastructure has held, but it's already weakened. You understand? When this one hits, you understand? The structure is already weakened, and therefore, when this second vortex hits, it actually just drops structures. I suppose like a boxer. In one round, you almost knock the person out, and he's already weak. And in the next round, you just need to touch the person, and he's going to fall down. So it's similar to a boxer. This is the one round, and this is the next round. Okay? Phenomenon associated with tropical cyclones. Storm surge, and if some of you maybe have last year's paper, had a little problem with this. You understand? Okay? But it's part of our curriculum, it's part of the system. Okay? So sometimes we may not have, the tropical cyclone may move over areas, but it may dissipate, may hit, like in South Africa, we have Madagascar, just before the tropical cyclone hits South Africa. And what happens when it passes over Madagascar? We've got a situation like this, and then we've got Madagascar down here. And what happens? The tropical cyclone comes in, you understand? And as it comes in, it has to pass over Madagascar. Okay? And what happens? It starts to dissipate. Sometimes it picks up some energy, and what may hit here is a tropical storm or storm surge. because most of it has died off and we lose the effects. For us, we say, thank you, Madagascar. That saves us a lot. You understand? Because of the friction. So a storm surge could hit the area where it picks up larger waves. It's not exactly like a tsunami. Don't mix it up with that. All right, tsunami is a massive wave. It picks up waves. It brings in heavier rainfall, stronger winds towards the coastline. And this actually can cause devastation. Inland flooding, where the water, remember, I always say this to my learners, when the tropical cyclone hits the coast, it doesn't sort of hit brakes and just stops there. The impact does go in. You understand? Fortunately for us, we have a steep escarpment. Okay, I'm talking about for the people in Gauteng, not for the rest, or on the Highveld. We have a steep escarpment. So by the time the air goes up, it may bring in a little additional rainfall, and the effects of any type of cyclone that had to hit us would be limited in the Highveld. Okay, but we could have inland flooding, where around, let's take, if it had to hit, like Des Moines was a cyclone that hit in 1984. It hit the coast of KZN, but the effects were felt in Pietermaritzburg and further up. So we could get inland flooding. Flash flooding, remember, as I explained to you earlier on, there was a region where there was 2,000 millimeters of rainfall over a short period of time. That's a massive amount of rainfall. So coming down like that, you understand, all of a sudden, we can't even make preparations. In that case, and it was in last year's, or was in 2010 paper, if you go through that one, you would realize that they couldn't even make preparations. They had a massive mudslide that affected the area. Okay, so it's quite an issue. And of course, urban area floods. Remember, our urban area is missing open land, I like to call it, or vegetation in most cases. We have a concrete jungle. So what actually happens in our concrete jungle? There is less infiltration. So there's more runoff that's coming through. So when it hits the urban areas, it can really cause a lot of destruction. Less infiltration, water just runs through. It floods, it damages power lines, infrastructure generally gets damaged. You understand? It actually can bring the economy of that little region to a standstill. You understand? People can't go to work because there's no work. Piped water is a problem. Do you understand? These areas don't have these things anymore because they've been destroyed. Okay, the effects even of the storm is far greater after the storm than even when during the storm or when the tropical cyclone hits, because after there's no piped water, there's no electricity, medical facilities are not functioning. So what is actually happening now? All right, waterborne diseases start to spread. There's lack of control. Crime starts to develop. Okay, with waterborne diseases, people can die. Money has to be invested to build their infrastructure again. Many companies have to close down for a certain period of time. Okay, so it's quite a huge issue. I just want to show you some of the impacts of a tropical cyclone. Look at this area here. Completely devastated. Look at the force of the water here. Okay, and these cars, okay, they look as if they're floating, you understand, in that water. Okay, look at the level of the water. It's one of the most devastating natural phenomenon that actually hits our areas. You understand? There's this guy taking some precautionary measures and actually blocking off his windows, etc., so to limit the impact of the water. You can even see here, all right, the strong winds that's actually bending those things. There was nothing, as a little boy, or not so little, I suppose, I've seen Cyclone Des Moines, and it ripped through buildings. In fact, it created gorges and separated houses in the area. It tore through bridges, and once when I looked down a bridge, the water seemed like tight pieces of string that were flowing. It didn't seem like it was flowing at such a fast rate. Okay, so it's a very devastating storm. All right, Let's look at the tropical cyclone on a synoptic map. Okay, you see the symbol, you know. The name will tell you it's a tropical cyclone. This is quite an interesting one. If you look at the distance between the isobars here and the distance between the isobars there, the isobars are closer here. But we always said the forward left-hand quadrant is where the isobars are closer. But remember, this tropical cyclone is going over land. And when it's going over land, what happens? It starts to dissipate. And therefore, the pressure gradient gets weaker in that system down there. So various ways of interpreting it. We got a little glimpse of Madagascar there. That's our savior. That saves us on most occasions. Because if it goes above Madagascar, it's far north, and it could affect the northern sections of South Africa, like Limpopo and the Kruger National Park. Okay, if it goes south of Madagascar, it's too far south and it starts going into the middle latitudes, which lowers the temperature. Okay, and therefore we don't get much effects and it starts to dissipate. Let's look at some exam type questions now, which is very significant. Let's see this one here. It says refer to figure 1. Okay, we'll make reference. Remember again, we read everything. And the extract on Haiti awaits another natural disaster. So the examiner has been quite nice here and has given us 2 pieces of information. Let's look at figure 1. We know we're dealing with a tropical cyclone. Look at how beautiful the eye is here. We can see the eye here. You can see how clear it is, eh? All right? But around it, we see this tight band of cloud. All right, that's our vortex. All right, on both sides. Okay, but it's clear, the eye. Also, what do we notice here if we look at the movement of the air? Can you see it? As it's moving in, it's moving anti-clockwise. Already we worked out in which hemisphere this is happening. You can see the movement is anti-clockwise. It's a low pressure, and air moves around a low pressure anti-clockwise in the northern hemisphere. Okay, let's go further. Let's look at this question, and now there's an article. Recently, Haiti developing country, very important point, okay, was hit by a massive earthquake which caused a lot of damage and loss of life. Okay, remember, you take a highlighter and you highlight the words as you're reading. After the earthquake, cholera spread. Remember, waterborne diseases. Haiti now is bracing itself for a hurricane that's going to come now. That is expected to hit the country. Okay, due to the earthquake, many people are living in tents due to the earthquake and makeshift homes. Many of these trees have been cut to produce coal, so we're removing the trees, deforestation, out of necessity. Remember, these people need that for keeping themselves warm and cooking, etc., energy source. A greater amount of flooding and mudslides are expected, again because of the lack of vegetation. Already our knowledge of what we studied is coming through due to the removal of trees. The spread of cholera is expected to reach catastrophic proportions due to the loss of life is expected, and the loss of life is expected. So this area has been hit by a massive earthquake, has caused enough damage already. People are removing the trees, and for energy supply, they're burning it. Also now it's going to be hit by a hurricane. Another little hint, the word hurricane also tells you it's in the northern hemisphere around the Americas, etc. Okay? So we've got quite a bit of information already in our heads. We already can picture. And I said to you already, if you do this all the time, you actually work out the answers. Okay, let's look at the next one. All right. Name system A. All right. System A, it was referring to the tropical cyclone. All right. So system A is the tropical cyclone. All right. Unfortunately, that got left out. But if it referred to that, we would know it's the I. If it referred to the whole system, you understand, it refers to the tropical cyclone. Okay? State 2, weather conditions associated with system A. From here, you would pick up that we are referring to the tropical cyclone in the first one. Okay? 2 weather conditions associated with system A. Now, again, this once, and it's very important to identify or define or whatever, because if we got the first part wrong and we couldn't identify it as a tropical cyclone, then we do have problems. We may, let's say we identified it as a mid-latitude. All your questions can go wrong. So quite often we have lead-on questions, I call it. Some people call it as ladder questions or various things. But it leads on from the first one, it goes on to the second one, and they are related. So it's very important to practice a lot on identifying your systems, etc. So 2 weather conditions can be any 2 weather conditions, all right? We don't have to be over specific. State 2 weather conditions. It didn't refer to the article, but we can talk about strong winds, all right? Or we can talk about hurricane force winds. Force winds. Okay. We can talk about torrential rainfall. Because there's a lot of rain that happens during this place. Okay, if you want to go in and then go into further ones, I like the more definite ones, but we can talk about massive cloud cover, massive cloud cover. I do apologize for those little things coming through. My technology is a bit limited. Okay, I suppose it's my age and gray hair. Okay, so massive cloud cover. Okay, that could be happening. We could talk about high humidity. Okay, so there's various issues, but you've picked that up already from our little content discussion early on. But I like going with these ones first because these ones show us the definite weather conditions, torrential rainfall, strong winds, etc. Okay, any 2, obviously, with a mark allocation would give you 4 marks. Okay, which part of system A is considered the most dangerous? Give a reason for your answer. All right, once you identified system A, you already worked out it's a tropical cyclone. You have studied, you understand, the tropical cyclone as such. Okay, so you know the forward left-hand quadrant is the most dangerous. Okay, so although maybe the diagrams may not give you so much information, okay, because we didn't show you the isobars being close there, but you can still work it out. So it's the forward left-hand quadrant. All right? What would be our reason? Remember, we spoke about it and we said that in the forward left-hand quadrant, the isobars are very close together. Okay? So we can give a reason. This is where the pressure gradient is the steepest. Okay, is the steepest. So that is why it's there, because remember the pressure gradient is steeper, air moves faster in that region from high pressure, or from low pressure rather, to high pressure. Okay. More super hurricanes are occurring recently. Explain why this is occurring. Again, no real reference to the article as such, but also telling us it's occurring. That is why a statement has been given here, that they are occurring. Now, in this question, we need to look at what is the main factor that brings about tropical cyclones? And the main factor, again, for super hurricanes and whatever, or any hurricane or tropical cyclone, whatever the name we give it, is temperature. And we need to ask ourselves a question: is temperature of our planet getting higher? Is the average temperatures getting higher? And yes, it is. What is the factor causing that? Is global warming. So we need to look at that. We need to look at what's a factor, because we could get stuck if we don't realize that the main thing that drives a hurricane is temperature. So obviously, if it's getting warmer due to global warming, which is the increase in the average temperatures. Okay, the increase in the average temperatures, which is making the earth hotter, okay, which leads to stronger or more devastating tropical cyclones. All right, just recently we realized what is happening, that there's more and more tropical cyclones we're hearing about, and they're more forceful, they're hitting every area. Even a place like America is actually struggling. You understand? In many cases, let's look at the next question. In many cases, especially in developing countries, the effect of natural disasters on the economy and living conditions and loss of life is greater than after natural disasters has occurred. In a single paragraph, explain why this is the case. This is a bit of a complex one, all right? Remember, economy is one, all right? Living conditions is two, okay? Loss of life is three issues here, all right? So there's three different issues we had to look at in order to answer this question. So we're saying all these things: the disaster on the economy, the disaster regarding living conditions, and disaster according to loss of life. Also, we looked at especially developing countries. Okay? So it's quite a few factors. This is quite a complex question here. We generally don't give you so many factors, you understand, to consider. Okay? We generally give you one or two factors in your exams. But if you can get through a question like this, you can answer many questions very well after that. Let's look at it. Number one, we looked at the developing countries. We can then state that, and again we're putting in a paragraph, all right? Effects, okay, the effects of natural disasters, like the one we mentioned, or tropical cyclones, effects of natural disasters is worse in a developing country. People, I'm actually doing it like this because it could assist you in the sense that whenever you look at a memo, all right, that you get from downloading or from your teachers, it's always written in point form there. You understand? It's actually done like that, so it makes it easier for the markers to mark your paper. All right? It just means taking those same points and putting them into a paragraph with full stops after each point. Okay? So let's just do it again. Effects of natural disasters. Sorry, I keep forgetting. All right, disasters is worse in a developing country, and we can go on to explain because they don't have good infrastructure. Okay, good infrastructure. I do apologize, learners. I'm just going to put it in short because then we're going to spend so much time writing, and I would limit my time with you talking about the strategies of the questions. So it won't have good infrastructure. We could also, in make a point here and talk about a lack of funds for emergency or lack of emergency services. Okay, any point to raise that issue, emergency services. Okay, anything. So if we is illustrating that and we're putting down just they don't have proper infrastructure, the economy is not very strong, etc., we can get our 2 marks. Then we could go on, and maybe I just want to go up first again, is looking at the economy of the country. It would affect all the economies of the countries, okay? Because here we could talk about, and I'm just going to put it in point form now, but you remember, you put it in sentences, a full stop, and you continue in that sentence. All right, we could here talk about, in terms of the economy, okay, destruction to infrastructure, okay, would lead to a distribution and transportation of goods, etc. So transportation problem, okay, transport, which would affect the economy. All right, money has to be spent, okay, on building or rebuilding the economy, isn't it? All right, which money is used up and therefore other facilities cannot be built, okay, rebuilding infrastructure, etc. Okay. Sorry, my spelling is a bit off, but I'm sure you would understand there. All right. Economy is that loss of life also could affect the economy. All right. Loss of labor, of life, which would mean loss of labor. Okay. No electricity. So there's so many factors that you could pick up here. Okay, so production is limited, and I could go on and on and on. Let's look at the next one. Okay, it talks about after natural storm has occurred. It affects the living conditions, and here under living conditions we could talk about homes destroyed. Okay, we can talk about no electricity. All right, so the living conditions, isn't that inconvenient? All right, again, I apologize for the spelling, but we would go on and we can talk about no piped water. So we could give various things related, but we related. Homes are destroyed, people are left homeless, they have to live in tents or temporary accommodation. So we take the point a little further. Just homes are destroyed. Don't just stop at homes are destroyed. People are left homeless, they live in temporary shelters, which makes human conditions very uncomfortable. No electricity. Again, people have to use candles and whatever. It's uncomfortable. No piped water. You understand? Then you have to get water from other sources, boil them, make sure they're not contaminated. So it's definitely uncomfortable human conditions down there. And of course, the loss of life, which is our last factor here. And the loss of life, again, we can talk about the floods, just drowning people, isn't it? Floods. All right, people drown. Okay, we can also talk about waterborne diseases, okay, that could kill people in the end because there's no proper medical facilities, etc. Even medical facilities could come in there, which is an inconvenience for people when there's no proper medical facilities. So your waterborne diseases can kill people. Now the important thing here is, do I check? I could write 10 points, you understand, on the economy, but I would not get my full marks. because I didn't cover anything, all the other aspects. I need to cover something from here, even if it's 1 point, something from here, even if it's 1 point, something from here, even if it's 1 point. You understand? Something from here, even if it's 1 point. But I promise you, you're not going to get 4 aspects. I just put this one in, quite a difficult one, and I said, let me just put it to demonstrate to you. So as long as you got 6 points, and was 6 times 2, 12, and you've included all the sections that need to be discussed, okay, and explained each point, then you would get your 12 out of 12. All right? Let's look at another one, another question. Study figure 1.3a, which represents a section of the world map showing location and movement of tropical cyclones or hurricanes in the South Indian Ocean. Or telling you where it is. Okay? You know already. All right? And the West Indies respectively. Also refer to the article on satellite images of Hurricane Ike. Okay? So let's look at our diagram. We can see the hurricanes, all right, tropical cyclone, and the hurricanes around the West Indies, and the tropical cyclones around the Indian Ocean. That's your northern hemisphere, your southern hemisphere, and you can see already, look how nice this one is, the anti-clockwise movement, all right, and this is the, this is the direction, I must apologize, that is your direction, that it's moving in the easterly trade winds, all right, and they're moving from east to west, and here also moving from east to west, all right, from the equator as such. But of course, here it will be, this would be anti-clockwise. I'm confusing you a bit here. This would be anti-clockwise around the low pressure, and this would be clockwise around that low pressure. There's a long story about Ike. 10 September, U.S. President George Bush made an emergency declaration for Texas in advance of Hurricane Ike, making federal help more available and preparations and evacuations, which meaning that he took these steps because they were expecting it. A state rural water association activated mutual aid networks to prepare for the landfall of Hurricane Hannah and Hurricanes Ike, so they were preparing for it, still providing assistance to areas impacted by Hurricane Gustav. The Texas Rural Water Association held meetings with the state agency on Tuesday, 9th September, to plan landfalls along the Gulf of Texas. So they're making preparations. On September 11, forecasting models began to show, all right, Ike making landfall just south of Galveston. City manager Steve LeBlanc, well, that's the name of the person, but they already started identifying. A mandatory evacuation order late Wednesday for low-lying areas. Because it's going to hit the low-lying area, you move people to higher areas. All right. Later, the mandatory evacuation order was extended to the entire island. So they're monitoring it. United States is a developed country. So it's monitoring how, where must they move. The impact is greater, they move more people away from the whole region. Also on September 11, 2019, the Weather System of Houston issued a strong worded bulletin regarding storm surge that's happening. Bigger waves, stronger winds started to happen along the shoreline of Galveston. The bulletin advised residents living in single-family homes in some parts of the coastal Texas may face certain debt. All right? Of course, I'm talking about force and face. This is a force that cause people to face debt. Okay? And if they do not heed to the orders of evacuation. Reports as many as 40% of Galveston citizens may have not paid attention to the warning. It was feared to be much the same in Port Arthur. All right, people have not listened, and this is a common phenomenon. Hurricane Ike was the 9th named storm, the 5th hurricane, and the 3rd major hurricane of 2008. Remember, they're named according to letters of the alphabet. Atlantic hurricane season. So it happened in that area. The satellite image below shows Hurricane Ike at the peak intensity. Quite a bit of information going through. All right, you see Ike again now. All right, and you notice here, it's the movement going in. All right, quite a big cyclone. You can notice the eye here, the white cloud around it. So it's a very forceful. You can even see the ocean around you here, how rough it is. All right, the swells, etc., building. Okay, look at question 1. Name one similarity visible in figure 1.3a between tropical cyclones in the South Indian Ocean and tropical cyclones in the West Indies. Let's look at that quickly. If you look at it, both move from east to west, common. Both, all right, originate from the equator 0 to 5 degrees and come out. All right, both affect the western sections, or rather the eastern sections of the country. So those are similarities. What is visible here? If they didn't say what is visible, you can talk about the weather conditions, etc. But if you look at it again, both are east to west movement. It's also, we look at it here, affects the east of countries. All right, both originate around 0 to 5 degrees north or south, depending on which hemisphere it was. All right. Let's look at the next question. Explain the point of origin of both hurricanes. We could repeat it down here. All right, that they occur around 5 degrees north, okay, depending on whether it's a hurricane. All right, that would be for the one in the West Indies, which is a hurricane, and then 5 degrees south, you understand, with the other one, which is the tropical cyclone around the Indian Ocean. So 5 degrees north, 5 degrees south. All right, and then let's look at the next question. Very intense hurricanes, such as Ike, may occur more often and more regularly. All right, many meteorologists think that meteorologists link the latter to global warming. Why is this so? We discussed a question on global warming early on, where we spoke about the super hurricanes. Now, it practically needs the same answer here, but it's phrased differently. And I purposely left these things because sometimes you could give a question in a test and then phrase it differently, and learners sometimes have a problem. Okay? It's actually the same sort of answers, just that in the last one it was a paragraph question of 12 marks. Here it is just talking about it as 3 points. 3 times 2, 6. Okay? So, why do you think this is so? And then you can talk about it. Okay? And here now, a slightly different approach. We can talk about the tropical cyclone and what makes a tropical cyclone tick, I would put it that way. And we can say, meteorologists link the latter with global warming. Why is this so? So we can say tropical cyclones, okay, rely, I'm just putting rely on high temperatures. Didn't we speak about high temperatures of over 27 degrees Celsius, all right, plus 27 degrees Celsius? And global warming will be assisting it to get those temperatures more often, okay? And global warming is increasing temperatures, isn't it? So they rely on high temperatures to form. Global warming is increasing temperatures, okay? obviously, if global warming is increasing temperatures, there will be more tropical cyclones. Also, we could add in a further points here. You understand? Because the temperatures are increasing due to global warming, what else will be happening? Okay, there'll be more air rising. Okay, therefore the lower pressure will get, or the pressure would be lower. Okay, what other factor that would increase the pressure? Because more air is rising due to global warming. I'm just going to put an asterisk down there. What else will increase? Okay, more humidity, isn't it? Absorbed. More humidity absorbed. And if more humidity is absorbed, there'll be more condensation. And if there's more condensation, there'll be more latent heat, which would make the temperature even go higher. And if it goes higher, we'll have a more stronger tropical cyclone. Remember, it's 6 marks. You just have to put any 3 of these points and you've got your marks already. Okay? And that's your 6 marks. Learners, unfortunately, the time has run out. There are more exercises that I wanted to go through, but you do have the booklet at home. And please, that booklet is not the end of everything. You make sure you get more papers on these sections, because on most years, tropical or mid-latitude, or tropical and mid-latitude has been appearing in our papers. So it's very significant that we do look at these sections and do as many past papers as possible. I wish you all the best. Once again, don't forget, in between maths and science and accountancy, we do need to revise geography. Don't leave it for the end. All the best, learners. Goodbye.